Good morning. In this wonderful video, we want to prove that this is equal to this, that f of a, b, c, x is equal to 1 minus x raised to power n, provided that a is equal to b using hypergeometric series. Okay? Solution. We know the formula that says that f a, b, c of x, okay, is equal to the summation of n starting from 0 to infinity of a subscript n, b subscript n over c subscript n, like this. Then you now have x raised to power n over n factorial. Please, you need to know this formula. This is hypergeometric series formula. Very, very important. And then we are told that a is equal to b. So if a is equal to b, now if b is equal to c, if b is equal to c, we are going to have that f of a comma b, okay, x like this is equal to the summation of n starting from 0 to infinity of a n bn over bn, because anywhere we see c, we can put b there. Okay, then x raised to power n over n factorial. So now if b take care of b, we're going to have that this is equal to the summation of n starting from 0 to infinity of a n x raised to power n over n factorial. Now, don't forget that our a is called the Pochhammer series or the Pochhammer symbol, where a of n is called the Pochhammer symbol, which is the rising factorial. Okay, is called the patch, P-A-C-H, yeah, Pochhammer symbol, or we call it the rising factorial. You can equally call it the rising factorial, also known as, aka, also known as the rising factorial. The rising factorial. So it means that a of n is equal, if you remember the following factorial, that n factorial is equal to n into n minus 1, n minus 2, like that, up to n minus up to 2, 3, 2, 1, like that. But this is a falling factorial. So the rising factorial is given as a into, you now change the sign, a into n plus 1, okay, n plus 2, n plus 3. It continues that way to, I think, to n plus 2. Okay, not n, but a. Sorry, not n. It's a. A into a plus 1, a plus 2, a plus 3, into a plus n minus 1, then into a plus n. Something like this. It continues. So you keep adding 1, you keep adding 1, you keep adding 1. So having this now, we will now have that. We can put it here. If we put it here, we will now see that this is now the summation, that f a b of x will now be equal to the summation of n starting from 0 to infinity of a. This an will now turn to a into a plus 1, a plus 2, then continues up to a plus n minus 1, then all over n factorial. Then I'm having x raised to power n. Now, we want to change this thing from rising to falling. So to change it from rising to falling, what we have to do is going to introduce minus, introduce negative everywhere. So we're going to have that this is equal to the summation of n starting from 0 to infinity of minus a. Here will now be what? Minus a minus 1. Here will now be what? Minus a minus 2. Then it continues that way up to minus a minus n plus 1. Okay? So we will now have x raised to power, we now have a bracket of minus x raised to power n. We're introducing minus everywhere, all over n factorial. So having this now, there is something I want to show you. If you remember the binomial theorem, says that a plus b all raised to power n is given as the summation of r starting from 0 to maybe n, okay, starting from 0 to n of n combination r a raised to power n minus r b raised to power r. This is formula for binomial expansion if you want to expand this kind of thing. Now let us assume that a is 1. If a is 1 now, and then let's assume that n is a. I want it to look like this. So let's take a to be equal to 1, then we'll take n to be equal to a. I just want it to look like this, and then we'll take r to be equal to n. Okay, let's have something like this. So it's going to be change everybody. We have 1 plus b all raised to power n is equal to the summation of what? N now. Sorry, our n is equal to okay, all raised to power a. Our n is equal to a. So all raised to power a is equal to what? N being equal to from 0 to a. We're changing all the n to a, and then all the a to 1. Okay, I just want it to look like this so that you understand it when I'm comparing. But if you don't want it that way, we can decide to just put a to be equal to 1. I just want you to see something when a is equal to 1. If a is equal to 1, I'm going to have 1 plus b raised to power n is equal to the summation of r starting from 0 to n of n combination r, 1 raised to power n minus r, then b raised to power r. And then you know that 1 raised to power anything is still 1, so that one is gone. So we are left with the summation of r starting from 0 to n of n combination r. This is gone, b raised to power r. Now, you should know that all this thing here is the same thing as saying, watch me, please, this thing here, this f of a comma b, b like this, x, is now the same thing as, all this thing here is something as saying minus a combination n. Okay, please know that this is the summation of n starting from 0 to infinity of minus a combination n. Minus a combination n, and then I'm having minus x raised to power n. Now, sorry, the n here should be outside, please. It should be outside. So now, if you compare this now to this, you will see that my x is equal to minus a, and my r is equal to. Now, if you compare these two things, see what is going to happen. You will see that your n is equal to r. Okay, then your b is equal to, or let me say your r is equal to n. Your r is equal to n, and your b is equal to what? Is equal to minus x, and then your what again? Your r is equal to n. Okay, I've said it. Then your n is equal to minus a. Your n is equal to minus a. So if I'm having that this is 1 plus b raised to power n, so this is now equal to, let us compare. This is 1. Our b is equal to minus x. So this is minus x. Then raised to power our n. Our n is equal to minus a. So raised to power minus a. Okay. So it is now proved. It is now proved. Okay. Sorry. The mistake here is minus a, please. This is supposed to be minus a. Raised to power minus a, not raised to power n. So please, this is the proof. It's now proved. You see that now? So it's very, very simple. So now an example is, if you know this now, and then maybe you are asked to prove f of maybe 1 comma b comma c comma x. I hope you know that from here that this is going to just 1 minus x raised to power what? Minus 1, which is something as 1 over 1 minus x. Okay? Proved. Provided that b is equal to c. Provided that b is equal to c. So thank you very much for watching. Please don't forget to like our video, share, and subscribe. Bye-bye.